Hello, my name is Darius Tai. Welcome to my presentation of my Mechatronics project for Engineering 415. It is the drawing robot. Before we discuss about the drawing robot, I would like to introduce myself and the course. For me, I am a senior mechanical engineering student with a controls focus, and I will be graduating this fall 2020. This course is a hands-on course that covers all aspects of design methodology. This includes electrical, mechanical, computer, and civil engineering. In this class, I learned about various industrial components such as actuators, belts, gears, etc. In this class, you will develop skills that will be useful for any job, such as learning basic design, like how to pick a bearing or which type of shaft you need. In addition, we also learn how to make a resume and a CV. Now I will be covering the project. To cover the project, I will need to discuss what the project came from, which is the engineering kit. The engineering kit is a kit that is designed for engineering students to learn how to develop very important skills for MATLAB, Simulink, and Arduino. In this kit, it consists of multiple components that will be used for these engineering projects. These engineering projects consist of the three that you see below, which is the drawing robot, the mobile rover, and the self-balancing motorcycle. Each of these will be using the lithium polymer battery and some type of sensor, actuators, the microcontroller MKR1000, and a programming language. All three of these projects are important for any engineering student to learn how to make projects using the said components and hopefully be able to design projects outside of the engineering kit. The drawing robot, which is the one I designed or made, consists of the same components that I said. It is a cable-driven robotic project that uses MATLAB. It is conducted on a whiteboard using string connected to the DC motors. These DC motors that you see at the bottom left is a DC motor that has encoders with it. The DC motor itself can drive the robot up and down. The encoder will be used for precise movement and distance measurement. By calculating the counts of the encoder, you should be able to move the robot's positioning. The servo motor will control the marker's positioning. By controlling the servo, the markers will be able to move up, down, and neutral on the drawing robot to decide which pen you would like to draw with. The webcam is our sensor that will be used for image capturing. This will be conducted at the very last bit of the drawing robot. And then we shall now cover the MKR1000 and the motor carrier. The MKR1000 is the microcontroller that is being used for this. It is a very complicated microcontroller that is able to control the drawing robot. The motor carrier is the most important thing here, for it's the one that is able to provide power using the lithium polymer battery to help the MKR1000 control all three of the servo motors. Without the motor carrier, it wouldn't have a shield, so you would be damaging the MKR1000. Now I'll be talking about the implementation of how I made this drawing robot. First, I will talk about how the drawing robot was controlled. In this, there were 7 tasks that need to be done, and I believe that tasks 3, 4, and 6 help the most in trying to control this robot. Task 3 helps you understand how to move the robot in specified positions. This was important for you to get the move to counts function because it is the main function that allows the robot to move around the whiteboard. Task 4 is also important because it sets position limits within the whiteboard, so the robot will move within the limited space that you provided. That is what the x-lim-pix and y-lim-pix variables are for. And task 6 converts any image's pixels to traces. This is important so that way any image that is being loaded or used by or found by the webcam will have the pixels converted to traces. I will cover this in more detail in the next slide. One of the most important things about the robot is the image capturing. For image capturing, there were 3 functions that I thought were useful. Transform pixels to meters was important to convert pixels into meters, as the name suggests. This is to be able to scale pixels onto the whiteboard. The cords would then take the image and connect the pixels to traces, which allows you to be able to use the pen and drive it around the whiteboard. And connect segments will take these pixels and make single traces, so that way you only need to make one to 3 traces in order to make the image. Although 1 to 3 images is only for the MATLAB logo, which I will go into more detail later. If you've been paying attention, the design procedure of this is first, MATLAB will load an image from the computer or webcam. Then the function image to pixel segments will extract the pixels and connect the segment into traces. This function is important because it takes the image capturing with those 3 functions and puts them all into one function. Third, the initial position function will consider the robot's current position beforehand, so that way it will draw within the specified limits that you set. And then lastly, the image will be drawn based off the image to pixel segments function. This function is very important for the image to be drawn. Now for the demo. For the first demo, I decided to draw the MATLAB logo. There is some discrepancy with drawing this due to mechanical issues, such as the string getting stuck within thing. And here is a video of it drawing. Although the quality of the video is bad, you can see that the robot is being controlled and it is going down, making a curve of what the MATLAB logo is. Next, I will show you what it looks like at the end. This is what it looks like at the end. I take it off to show you how it looks like now. As you see at the bottom of the image, that is due to the discrepancy of the DC motor affecting the image. Here's a close-up photo so you'll be able to show that it did make traces. These traces, the first one making the outline, one going across, and then one coming from down up. Those are 3 traces, and this is due to the connect segments function that allowed it to do that. Next, I used the webcam as a sensor in order to do live photo capturing of this picture. It is a smiley face, and here is a video of it being drawn midway through. The reason this video had to be shown with it already being drawn is because the robot likes to trace over certain lines, and then it also which adds more detail to the picture. Within the coding, it is possible to add less detail, but I do not know if that will affect how good the traces will be. Nonetheless, it finished its drawing, and here it is. This is what it looks like after it was done drawing it. One can get a better drawing of this if they decide to add more detail using the given functions from earlier. Here's a final picture of it. As you can see, it made a perfect circle as well as a smiley face, the 2 dots, and then the eyebrows. Thank you. I hope you enjoyed that. Here's my email and my LinkedIn, and I hope you appreciate my presentation.